I'm going to start with a little bit of weather, a bit of climate, and then getting to climate change to provide some background information for the rest of the speakers and tee them up. So the big difference between weather and climate is time. Weather is the changes in sunlight, temperature, precipitation, humidity, wind that happens in the seconds, minutes, hours, and months. Whereas climate is what happens on a longer time scale, more months, years to decades. And climate is also looked at not only over these longer time scales, but also can be looked at over larger spatial scales. We don't really talk about the weather of the globe, but we do talk about the climate of the globe. So what's happening over the entire Earth's surface. With climate, small individual extremes, so one really hot day doesn't destroy when winter happens. Winter is expected to happen in our coldest months here in Salem in December and January, where we expect that summer and our warmest temperatures will be in July and August. In this slide, we have time going on the bottom and difference in temperature from an average global temperature, so the temperature across the entire Earth from 1961 to 1990, which is this window of time that's been highlighted there. And so taking what that average is, how does then looking from 1850 to 2017, how do those temperatures differ from that 30-year average? Climate generally is looked at in 30-year intervals, so it's 30 years of data, hence that one hot day or one cold day doesn't throw off the whole average because you need many warm days or many cold days to actually change what the average temperature is. So looking at that, we're seeing that the average temperature in the 2000s has actually gotten a lot warmer than that 1961 to 1990 average in comparison to the past. So what's happened recently across the globe? So this one's looking from 1881 to 1910. That was first green line that was on the graph. So this is pre-industrial temperature. How has it changed? And when we're looking at the warmest years on record since 2018, so not including this year because the year's not over yet, we've had the last 5 years have also been the last hottest years in comparison to that 1881 to 1910 temperature around the entire globe. What other changes have we seen recently? This last November was really dry for Western Oregon. So based on the data that we have for Astoria, Eugene, and Salem, 125 years, but only 75 years in Portland, the driest in either the third driest for Salem, whereas the fifth driest for the other locations. I mean, less than an inch of rain when usually Salem gets 6.5 inches of rain. These are just some of the changes that we've experienced. I don't know what you were thinking this spring when you were seeing the news reports in March of wildland fires. I was personally worried that this was going to be a really, really, really bad wildfire season, seeing that things were already starting in March. Things were drying out. But in reality, it wound up being a really short season, less than 100 days of wildfire season, the shortest in a long time for Oregon, which was great news. Happy for that variability when it's not to the extreme side. So what is going on? What is causing this? We link it to greenhouse gases. That would include water vapor, carbon dioxide, methane, and nitrous dioxide. These provide us our atmosphere. This is what gives us, this is our insulating blanket that traps the some of the sunlight to provide the warmth. Without it, we would be quite cold and more similar to, say, Mars in having a much cooler temperature. So this is our greenhouse gases provide us with our warm environment that we enjoy. However, we've been, as humans, we've been emitting a lot of greenhouse gases as well as making new gases that did not exist in nature. And those are going into the atmosphere and trapping more and more of the sunlight and not allowing it to release back into space. This is causing then the entire globe to increase in temperature. Here we have from 1960 to the present year on the bottom, and then on the side, parts per million, how much carbon dioxide has been in the atmosphere. This is at an observatory on top of a volcano in Hawaii that is not an active volcano, Mauna Loa. And The peaks and troughs that you see of the red line is the growing season of the northern hemisphere. When the plants are out, they're taking in that carbon that draws it down. Winter comes for the northern hemisphere. That the majority of the plants are in the northern hemisphere. You then see an increase because they're not pulling that carbon dioxide in. And that pattern happens, you can see it consistently happening across time. In 1850, there were 260 parts per million carbon dioxide. Currently, we're around 410. This is the highest amount in over 800,000 years. In short, the Earth has gotten a lot warmer. Locally, looking at weather stations, in this figure showing you different weather stations, red indicating warmer temperatures, blue indicating cooler temperatures, and then the size of the difference in temperatures ranging from 0.9, the smallest dot, to 3.6 being the largest dot. We've seen that there's been an increase in temperatures since 1920 to 1.6 degrees Fahrenheit. Almost every station shows this warming. There are some that do not. We're finding extreme colder temperatures are not happening as often. And that we're seeing minimum temperatures, so your cold evening temperatures are rising faster than the maximum temperatures. This is going to be important for our tree species and not getting their chilling hours. If it's not getting as cold, they may not be experiencing the sufficient chilling hours that they need. Some other changes that we've seen, the USGS monitors some but not all glaciers. Nearly every glacier in the Cascade Range has retreated in the past 100 years. The picture here of the South Cascade Glacier, 1928, the top figure versus 2016, the bottom figure, showing you the change in that glacier. And the USGS has found that these have decreased by 46% since 1900. Other changes that we've seen have been a decrease in snowpack, a recent publication by Phil Mote and his team looking at snow water equivalent. And so you can have light, fluffy snow or really dense snow. You melt it all and you get an idea of how much water is within that snow. So they looked at data from 1955 to 2016, and in this figure looking at the different stations, again the size of the circle saying the amount of change, whether 20% with the largest one being 80%, and then blue is actually an increase being like more snow, whereas red in this case being drier, less snow. And so we're seeing really large decreases in snowpack throughout the entire West. And the reason that we're seeing this is due to the warmer temperatures that our snow-dominated watersheds are transitioning to being more rain-dominated watersheds, or more of a transitionary and having a bit of both. Looking at projected temperature in the Pacific Northwest, walking through this figure, time on the bottom, the black line is showing you the observation. The gray is the uncertainty due to the models, because this is the going for a larger area, and there's some variation due to the different models, which are shown by the individual tinier thin lines. And then looking at two different future emissions scenarios. Business as usual, so continuing our greenhouse gas production, that would be represented by the red line, RCP, or represented conservation pathway 8.5 in red, whereas if as a globe we're able to work together and reduce our greenhouse gas emissions, that's represented by the RCP 4.5 in blue. I point out here that these two models really start changing their paths and overlapping less and less about mid-century, 2050. It looks like things are really going to be changing dramatically at this point if we remain on the business as usual and continue the greenhouse gas production and going to be getting increased temperatures. What the models don't do well at is precipitation. So all of the variation around these lines is indicating the uncertainty. So in short, we're not really certain what's going to happen precipitation-wise. There's a slight increase for both of the models, but in general, all of that variation, kind of everything is an option in terms of extremes of too much precipitation and not enough of it. So year-to-year variability is looking likely, lower precipitation, extended droughts are expected, as well as these atmospheric rivers coming through and dumping a lot of precipitation in a short period of time. I serve Alaska as well as Oregon, Washington, and Idaho, and I can tell you Juneau, southeastern Alaska just had this is a rainforest, 2 years of drought, followed by an atmospheric river that caused crazy flood damage in Juneau and destroyed roads. And so we could see these coming right after each other, of going from really dry and then having an atmospheric river. And so we need to prepare ourselves for all extremes. So getting to the what does this look like? What do these increases in temperatures look like? There's a nice tool out there for some of the cities that give you an idea of what other location will we look like? What does that climate look like? Try to wrap your head around what it means to have a few degrees in warming. And so for Salem, future climate will look like Granite Bay, which is northeast of Sacramento. So what we know is that there is a natural greenhouse effect. Without it, we wouldn't be here. The Earth as we know it wouldn't be here. However, we are contributing to it by adding additional gases that are making it warmer, as well as creating new types of gases that didn't exist previously that are making it warmer. And climate change is already happening and apparent, and will continue to happen. It will be, which path will we go on will depend on what we do as a globe in terms of modifying our greenhouse gas emissions. Okay, so we know climate affects affects our ecosystem processes. What environments we have, what plants are growing depend on what the water is, what the hydrological cycle is. Who grows, what establishes, who dies, again, based on what climate we have, what temperatures are there, the precipitation. Also disturbance, what the role of fire and insects are, again, dependent on the climate, definitely influencing the ecosystem processes. So now we'll look into how watersheds are expected to be affected. So at the top we have the historical watersheds for the Northwest. If they are rain dominated, that is represented by green. If they are transitional, meaning a mix of rain and snow, is represented by red. And snow dominated is represented by blue. And then two different climate emissions scenarios are the two columns, looking in the 2040s and out to the 2080s. And with these projections, we see a lot of the snow-dominated watersheds becoming more transitional, meaning a mix of snow and rain. Again, this is all just due to the increase in temperature, which we're certain about. And then the transitional watersheds becoming more rain-dominated. This can then also impact our flood risk throughout the Pacific Northwest. In this figure, the larger and darker red the dot is, the more likely of a flood risk. So we can see that's really high for eastern Oregon and Idaho, whereas more of a moderate increase for the rest of Oregon. We have seen some of these hydrological extremes recently with the Willamette flooding in Corvallis just this spring. With future climate change, will affect our stream flows. So this is looking at the Willamette River in Salem. This is at the climate toolbox, which I'll chat about again later. And the black line is showing you the historical stream flow, so the amount of water coming through the stream throughout the water year. Water year starting on the 1st of October, going to the end of September for the end of the water year. And then showing the two different emissions scenarios. And with this, we're seeing that the peak is still happening at the same time, but more water is expected to be released. But then more water is less water will be available later in the spring. Whereas for the Rogue River, this is at the Lost Creek Lake Station. Again, looking through the water year and how much water is released, We're seeing that the peak will change, as well as a reduction in water in the spring when plants are growing and pulling in that water, and when fish would like to be swimming in those streams. These shifts in when water is available for different streams and when the peaks are happening, if there are changes in peaks, a lot of this again is driven whether the watershed is more snow dominated, rain dominated, or that transition. And as they switch between the two, what changes that will mean for the individual streams. With these changes in streams, there's going to be a lot of fish that are affected. So this product from NOAA is showing you different salmon species represented by different shapes and their vulnerability to climate change. So with the higher temperatures, air temperatures will be warmer stream temperatures, will also reduce the flow rate. How vulnerable are these different fish populations? So the darker red meaning highly vulnerable versus yellow, green being less vulnerable. And we can see there's variation among the different fish species of which will be vulnerable and where throughout the West. On the flip side, we have the low flow risks, as we were discussing, versus the extreme wet side. So here, the darker dots indicating the chance for more low flow risks. We've been experiencing some of that already, some of these hydrological extremes of not enough water, whereas Prairie City last year was hauling in water from John Day because they ran out of water. This year on the Olympic Peninsula communities were also hauling in water because they ran out of water. Well, I didn't expect that. I think many of us have been surprised to see who's been needing to haul in water and where, when we typically think of these places as wet and water being the least, or having excessive water being the norm and not having to worry about not having it. We've had a number of droughts and abnormally dry periods. We're currently in an abnormally dry period. This is a map from the US Climate Monitor. And just to explain what the information is showing you, they take the climate data and organize it from the most amount of precipitation to the least amount of precipitation. And then those records, anything that is, the highest 30 to 100%, so the top 70%, that is not considered drought. You got a lot of rain, you're good, that's what's normal for you. But then when we get to abnormally dry, that is the least amount of rain going from 30 to 21%. And then we get down to 11 to 20%, and smaller and smaller. And so here, this is a planning tool to say, hey, right now it's dry. You may want to consider this and look at this if you're planning certain actions and how that may affect and what impacts those may have. So 2015, is highlighted as a year of all the various things that we've experienced as what the Northwest may expect to have in the future. So the National Climate Assessment was released last November, and in there they highlighted 2015 as what we can expect. And so I've blown up that middle section to highlight some of those challenges. I recommend reading this. It's available online to the public and has a lot of great information. There's a Northwest chapter as well as a forestry chapter and a number of other chapters you may be interested in. But we see challenges that were in 2015 and expect to see in the future: reduction of recreation, wildfire impacts, declines in first foods, harmful algal blooms, concerns about drinking water, wildfire infrastructure damage, irrigation shortages, heat and drought impacts to agriculture, coastal fishery losses, also spikes in heat illnesses, record causes of infectious diseases, and increases in emergency food assistance. By getting to experience this, we got a glimpse of what the future may be like. So now's the time to start making these changes so we can be prepared, so that the impacts aren't as extreme. Again, 2015, a big drought year. Switching gears back to the forest of who else likes drought? Our mountain pine beetle. Our native insects do enjoy it because the trees get stressed and then they're able to have a great impact. And Christine, I'm sure, will be chatting about this more later. With the warmer temperatures, insects in general can reproduce more. With warmer temperatures, they may also be able to change their range and go into areas where they were not previous or not a huge concern in the past. Since 1990, we've seen over 50 million acres affected by the mountain pine beetle throughout the West. There is a projection tool that's looking at the last few years of drought and then giving an indication of what the likelihood of this year will be for mountain pine beetle. And so as you get into the warmer colors, that's increasing the chance that those areas will be impacted by mountain pine beetle. So this is a tool you can look at to get a sense of, is this something I should be worried about in my region or not? Matt Riley will be chatting about this a lot more, but there's always the question of how climate change will affect wildfire. Looking throughout the United States of our recent past, going from 1985 to the present, as of the 3rd of December, how many wildland fires on acreage has happened. So acreage is on the left-hand side, and then the little green dots are showing you how much we've spent on battling our fires. Recently, there's been an increase in a lot of large fires occurring. Fortunately, this year wasn't so bad for us, though I can say, just pointing out for 2019, over 4 million acres, half of that was just in the state of Alaska. Thinking about what's happened to us recently, 2012, our largest fire in Oregon, over 500,000 acres were burned at the Long Jaw Fire. Generally, again, increases in temperature mean that plants are going to lose their water. There's going to be more evaporation happening, and so there's going to be a lot of drier tissues. With that, you're going to have more fuel. With that, because you have large areas of a lot of plants experiencing warm conditions, there's going to be this synchronization, fires all happening at the same time, which is going to be challenging for contending and fighting those fires. In 2015, again, that hallmark year of what was happening then and potential of what we'll see in the future, in Oregon and Washington, almost 2 million acres were burned, and across the West, over 9 million acres were burned. Several fires even occurred on the west side where we're not accustomed to experiencing them, particularly in the coastal temperate rainforest of the Olympic Peninsula. This year was lovely and no smoke or limited smoke, but the last few years it's been quite smoky and a challenge for day to day. And so in general, climate has impacts on our fire, on our insects, on our vegetation, and then they interact with each other, which makes it complicated to say this is exactly what will happen. But in general, with these warmer temperatures, we do expect that there will be an increase in fire. So in this figure, the darker the color is indicating the percentage increase of wildland fires. And so in the West and in Oregon, we're expecting to have 2 to 3 times higher wildland fires burning come mid-century than what we've experienced in the past. So in terms of what to expect, we know it's going to be warmer, which will then lead to more wildfires and less snow and less water in the summer. We're not really sure what's going to happen with precipitation because the models are not great at predicting that. So that's a big question mark. But because of the warmth, we do expect there to be more droughts, more floods, more wildfires, and each of these alone have a big impact on the ecosystems. 2050, depending on which trajectory we're on, things could change really dramatically if we haven't made changes to our greenhouse gas emissions. And likely there'll be surprises. There are things, we're in a realm that humans have not existed within. With so much carbon dioxide in the atmosphere, all of these changes happening, we likely will not, be able to anticipate everything that will be happening. And so with this, it's like, we'll then I'll go into how can we prepare, how can we, and as will the other speakers, but these are the times where we need to be making changes because a lot of challenges are coming our way.